today we are going to see about sound. Now, to start with, let us know what is sound. We can close our eyes for just a second and listen to the distractions that are coming from. What you are watching, is it a high pitched or deep or a low sound? Can you recognize it? Sound is made when an object vibrates. Press your fingers to your throat and speak. Can you feel the vibrations in your throat when you speak? You can just take a tuning fork, strike it, and then touch it and feel the vibrations that it makes. These vibrations, they travel through the air and they reach our ears. These traveling vibrations are called sound. Many sources of sound are there. Have you ever noticed the natural sounds? The thunder, for example, the rustling of the leaves of trees in the wind, the natural sounds like rainfall. All these are natural sounds, but we can yet make artificial sounds. For example, you can just take a plastic cup, tie a small rubber band over it. Now you pull the band. What does it do? It vibrates and it makes a sound. So, if you close this box and if you just strike it over it, again it makes a noise or sound. This is the sound we hear in drums while we beat the drums. So, sound can be made just by striking or pulling out the object. So, these striking or pulling out the objects makes vibrations. Have you ever seen sound? Can we see sound? Just I will make a demo for you. Now I strike the tuning fork and dip it in the water. You can see clearly how the water spills over. This is due to sound. Now you have visualized the vibrations of the sound. Now you can clap your hands. When you clap your hands, what happens? The air between your hands that starts vibrating. When you give pressure, the molecules between the hands, what they do? They vibrate and they reach our ear and makes the eardrum vibrates and we are able to hear the sound when we clap. Sound needs molecule to move. So it is impossible for the sound to be heard in space. In space we cannot hear sound. What may be the reason? Because we don't have air in space. So sound, to propagate sound, we need a medium. It may be a solid or liquid or a air. Now we saw through the demonstration that how sound traveled in water with the tuning fork. In space, since there is no air and it is vacuum, sound will not travel in vacuum. Since there will be no vibration of air molecules or water molecules or solid molecules. Light travels at 186,000 miles per second, but sound travels only at 770 miles per hour. Sound travels much slower than light, whether it is in air or in water. We often hear things after you see them. For example, you see the lightning before you hear the thunder, because light travels faster than sound. You can try this at your home. You can place a filled balloon between two people, maybe within your siblings. One of you talk against it and the other places their ear against it. Take turns. You can feel the vibrations of sound. See, we have all noticed that in yesteryears that we used to make a string in paper cups and place one end of the cup in our ear and the other end to your friend or anybody, and you will be talking, so that the sound will pass through the string and it will vibrate through the eardrum and it will be heard. These are all the simple experiments we can do at home to show that sound is vibration of particles. Two types of sound waves are there: longitudinal wave and transverse wave. But usually sound waves take only the longitudinal waveforms. It doesn't take the transverse waveforms. So then, can you imagine the detectors of sound? Our ear is one of the detector of sound, and the microphone we speak, that can be another detector, and sound level meter. All these are some of the detectors of sound. How are you going to measure sound? Frequency. For that you have to know certain terms. Frequency. What is frequency? Frequency is the vibrations of the particles made per second. It can also be called as pitch when it is referred as compressions and rarefactions. To know about compressions and rarefactions, the waveforms will be very dense. It will be in a compressed state. So it is a compressed wave. Here down you can see the rarefied wave. Here the particles are not so compressed. The waveform doesn't get compressed. It is loose. It is rarefied. So the pitch can be defined as the number of compressions or rarefactions per second. You can make a high level pitch. By singing, you might notice that you can take a high level pitch or a very low level pitch. These are all due to the compressions and rarefactions of sound waves. Then what is amplitude? See, this is a sound wave. Here you can notice that the highest distance it takes is the amplitude. So the distance between two maximum amplitudes causes the wavelength. That is the wavelength of sound. Sometimes we say sound as loudness. When the perceived strength of the sound has a high frequency, we tell it is loud. What is the intensity of sound? Intensity is nothing but the energy transmitted or carried by the sound wave. It is always measured in decibels. Decibel is a unit of intensity and hertz is the unit of frequency. Sound can be measured in both ways, in decibels as well as in hertz. If it is in intensity, we measure it in decibel, and if it is in frequency, we measure it as hertz. Now we have defined what is wavelength, the distance between two successive crusts or troughs. What is crust? The maximum distance reached by the wave is called crust, and the minimum thing is called as the trough. So, the distance between two successive crusts or troughs is referred to as wavelength. Then what is the time period? It is again the time taken between two compressions or rarefactions to cross a fixed point is called time period. What do you mean by frequency? The number of compressions or rarefactions per unit time is called frequency. The volume of loudness of a sound depends on the amplitude. The force with which an object is made to vibrate gives the loudness. If you give lot of force, then the object may vibrate at a huge rate. Then we say that it is loud, the sound is loud. So higher force gives higher amplitude and we hear a loud sound. Wave speed. The distance wave travels in a second is equal to the wavelength into number of waves each second it travels. Usually sound waves, what they do, they get diffracted at the edges. Like light waves, diffraction occurs in sound waves also. Sound waves diffract through a doorway or hills and buildings, like that. Beats. Have you heard about beats? Two waves with slightly different frequencies, their phase relationship constantly changes. This type of wave is called as beats. So we can tune the musical instruments according to the beats. We have to know what is node, antinode in a wave. Here the nodes are the 0 points and the antinodes are the maximum points. So the wave can be referred to as standing wave. When two waves pass through each other, they will be in phase and they are called as standing waves. So node is the point of 0 amplitude and antinode is the maximum amplitude point. So now we can conclude the session by seeing what are the applications of sound. It is used in speech and hearing thereby. Those who are unable to hear, we are having speech machines and hearing machines. Hearing impairment now can be rectified very easily. Sound transmission and production can be made through our commonly using mobile phones. We have lot of applications in this mobile phone, from radio to TV films. And many musical instruments also operate on sound, whether it is guitar, drums, violin or anything else. We can also have the flute which operates with the air. So sonar is another instrument which is used to detect the enemy submarines under the sea. In medical also sound plays a greater role. like ultrasound images, flaw detection, and also in cleaning jewelry. So we have lot of further applications that are coming in this modern world.